So we should commence. Attendance seems to be getting from bad to worse, but the show must go on, like they say. So let us proceed. We are now on to the final chapter of Transportation Systems, Module 6. And so after this module, you will then have all the documentation, all the tools to handle test 1. Just talking about test 1, maybe if I could have a quick early ad break. I know at one of the lectures, the student did say that he's up in Ladysmith and he may not be able to attend the test. And I just want to take you back, a few years back, all lectures were on campus, all assessments were on campus. That was before COVID-19. And calling it 19, yeah. And which means that if DUT res was not approved, that student would not have attended lectures or assessments, which is dangerous. And I'm saying this because at the end of the day, you need to have a plan B in place. You cannot rely or depend solely on DUT res. Who knows, the violence might just escalate next week and res might be closed permanently. Then what? What happens? So all I'm saying is that you need to have a plan B or even a plan C in place. Now, obviously, I cannot dictate what your plan B or C is. It will depend on your limits, your range, your terms of reference. So it's very important that you take note of that. At this stage, test 1 is still as scheduled. So I have requested for the S10 basement to run the test to satisfy the COVID protocols, safety protocols. We don't have a venue, 160-seater venue on campus in the department. I need a 160-seater venue based on a 50% capacity to cater for all of you. So I'm hoping that I get approval to use the S10 basement for the test. Okay, so the test, as I said, covers up to this module that we are discussing today. So this brings us to an end of, well, two major chapters, transportation planning and transportation systems.
Sorry, sir.
Yes.
Sorry to bother you, sir. Can you just repeat the test date if possible? Sorry, just so I can.
Yeah, I will send a reminder out on via email and post on Moodle, but if my memory serves me correct, it was the 15th of March. I'm quickly going into my diary, my calendar. Yeah, it was the 15th of March, and it will be during the lecture slot. The first test one is a 1 hour test. It's not a long test, maybe 34, 35 marks, test 1. So we will look at maybe 10:30 to 11:30. So that falls within your 10 to 12 lecture period or 10 to 10:50 lecture period. So expect the test to be between 10:30 and 11:30 on Tuesday, the 15th of March. That's not far away. It's under 2 weeks' time. So please do some revision towards test 1. And I will give you more details once the venue is confirmed as well. So we are to the last module, module 6, which deals with urban transit systems. Now, urban universal terminology for passenger transport, public transport. So basically, urban transit systems relates to passenger transport or public transport. We are simply using the universal terminology there. So you have a few definitions like urban transit or mass transit. So when we talk in terms of mass transit, you can see the keyword highlighted where your service provider or your public transport carrier works on established routes, fixed schedules. So you have fixed schedules, you have a published rate and fare, so you know exactly what's the fare to travel on that fixed route from A to B or C to D, whatever. So that is when we talk in terms of mass transit or urban transit. Then we also have paratransit, and with paratransit you can see the basic difference is that the public transport carrier system does not necessarily operate on a fixed route or schedule. So it could deviate depending on the demand, depending on the request, like you have, for example, a taxi or an Uber system, dial a ride. So you request the Uber to pick you up at home and to take you to some destination. So it does not follow a fixed route. So that falls under paratransit. And then we have the charter service. With the charter service, you can see the keyword there is contract. So it's based on a contract. So it could be a contract between the travel agency and maybe an individual or a company for that matter. Like you can see an example at the end there where a company could charter a service with ComAir, an air company, or you could, if you may be owning a business, maybe a supermarket, and you would like your employees to get to the supermarket on time, and you could then come up with a contract with the transit agencies to pick all your employees. So the route obviously would be marked off where to pick the employees and bring them to the supermarket. So it could be a charter service, similar to a charter service, which is based on a contract. You're all quiet, so I assume that you are seeing my screen. I didn't ask for confirmation, so I assume you all are viewing my slides. I'm now on to the second slide, a few definitions, and the first definition there you have is right-of-way. So when we talk in terms of right-of-way could be, for example, your road, shared amongst your cars, buses, trucks, motorcycles, and so forth. It could be semi-exclusive, like you do have some light rail transit systems, like a tram system that shares the roadway. So you have your rails fixed onto the roadway, could be on the side of the roadway, could be even crossing a roadway path by means of an intersection. Or you could have an exclusive right-of-way, like your rapid rail system, exclusive right-of-way. With the semi-exclusive, it could be a lane that's set aside, reserved for public transport, reserved for maybe buses, or even for that matter, even reserved for HOV. Now, when we're talking in terms of HOV, high occupancy vehicles, so if you have maybe more than 2 or 3 occupants in your vehicle, then you can use the reserved lane. Okay, so that will fall under the semi-exclusive. So then you have guideways and infrastructure. In terms of guideways and infrastructure, we're basically referring to your tracks for your rail. For that matter, you could have a track for your monorail, which is a control system, power distribution. So all that falls under the guideway, the infrastructure, building of your rails for your train, for your monorail. Revenue vehicles, well, most of your public transport operators, all here in South Africa, overseas, are certainly revenue vehicles. Revenue vehicles meaning you pay for the service, whether you're on a bus or whether you're on a minibus or a train. So it's a paid service. And you can see there's various categories of public transport carriers. Van is again a universal term, which is similar to our minibus taxis here. Basically about the smallest type of public transport carrier, and it could vary from carrying 6 to maybe 15 persons up to about 15 is more your minibus taxis, and then you do have the smaller so-called vans that carry 6 to 8 passengers. And then we come on to a minibus. Here in South Africa, we generally use the terminology more MIDI bus, M-I-D-I, like your minor system, carrying more than 16 or 15 passengers and moving from area to area. Then you have your bigger buses, your transit buses, that's more than 7.5 meters long, usually diesel driven, propelled. And then you have a whole range of different types of public transport carriers, and I'm not going to label each one. You can go through it, but very quickly, maybe randomly, if we look at a trolley bus, many moons we had this in Durban and in Gauteng. Gauteng was very popular for these trolley buses. These double-decker buses were propelled by electricity, so you have these overhead wires and the link from the overhead wires, which is electric, maneuvers or drives these trolley buses. And if you do come across pics of that on Eloff Street and other main streets in Gauteng, you will see these trolley buses. And then, of course, you have your general articulated buses, more diesel or electric operated. Some of them, or many of them, have a trailer attachment for baggage. Then you have what we call the LRV, which is a light rail vehicle. This is electrically rail. It's simply a rail vehicle. It could be a single unit, or it could be a number of coaches. And this is now what I refer to as the tram system, where you could have your rails on your road network, on the side or across your road network. So that is why we refer to it as semi-exclusive right-of-way. So it's sharing the road space with motor cars and other public transport operators. Then you have the rail transit car, which is with the rail transit car, generally you're looking at exclusive right-of-way. We're referring to your trains, commuter rail cars. These are commuter rail cars are similar to your light rail that we spoke about now on above, the LRV. But the only major difference is that it has a higher capacity than the tram system. And then you have the LRT and the HRT, and the basic difference between those two, the light rail, very often it's the shared right-of-way with other transport networks, whilst the heavy rail system has a dedicated right-of-way, totally on its own, like our rail system. Some service definitions you have when we talk in terms of local transit. Local transit, we're referring to making frequent stops. And generally by making frequent stops, then you would expect the system to have low speeds, like our minor system, moving from area to area, picking up passengers, making numerous stops. So you'd expect slower speeds compared to the next one, which is the express service. And with the express service, you can see the keyword highlighted there, faster speeds, certainly selected number of stops. So you'd expect fewer stops, more widely spaced. In terms of basic service is service that operates all day. So it's all day, 5 days a week, more to cater for your working class over the length of the day. And you can then see when we talk in terms of peak service then is more during the peak demand period, operating during peak demand. Then we also have special services. Special services could be during festive season, during holidays, maybe the Easter weekend, you have a special service taking you to a special event, a gathering. And then we have short haul, and with short haul, we're referring more to linking different major activity centers over a short route. And you know, the last lecture I did speak about the proposed monorail system along the beachfront, linking all your hotels to Suncoast. But unfortunately, that did not materialize. So that gives you some information in terms of service definitions. Focusing on some of the public transport modes. And there you have the bus system, the bus transit system. And with the bus transit system, you can see some information there on the trolley buses, the buses. So it's a fare-paying system. It operates on your normal public roads, your streets, frequent stops. And you could have varying quality of service. So in other words, you could get a hi-fi bus or a bus that's virtually falling down. So the services could be varied, the reliability as well, breaking down, not properly maintained. Comfort could vary as well. So you can see, and therefore it is necessary to have proper maintenance of your buses. In terms of cost, you have your capital cost, which is certainly the highest cost now in terms of buying the vehicle, buying the bus, and the prices obviously vary depending on the model, the size, and so forth. And you have your operating costs, which includes your wages, paying the driver, the conductor, fuel, tires, maintenance, and so forth. And not to forget that your total cost must take into account both the operating and your finance charges. Then we have the paratransit, your combis, combi taxis, and there's various types of combi taxis. So they are used more for a smaller number of passengers. And again, it's more informally operated, basically a door-to-door service. And there's different types of paratransit. You could even get a manual pedal operated or a motor rickshaw, minibus. Places like Bangkok, India, they have what they call the tuk-tuk system, three-wheeler motorcycles. So there's various types, and they could be used all day long. It's very suited for peak, off-peak. Because they are small, they can weave through traffic. So you can see it does some of the services these paratransits offer include personalized door-to-door service. It could be a shared service as well, shared service in a sense. I may want to go to the Pavilion Mall and individual B also wants to go to the Pavilion Mall. So en route, the taxi picks me up and then picks individual B and get to the mall. So it could be a shared service, and it's quite a regular service, and very often the routes are well defined. So if you're getting from areas to maybe malls or wherever, or to Brit City complex or to industrial areas, so forth. So very often these routes are well defined. Then from the road moving a bit onto the rail system, you can see we have the light rail system. And with the light rail system, yes, it is electrically powered. And we spoke about the tram, so it could range from the tram, which is the lowest order, right up to your metro rail system. So in other words, it could be shared roadway or exclusive right-of-way. And some of the basic features, you get passengers that usually board from either the road level or it could be underground, so lower level platforms, like the tram system, which operates in single units, or short trains, slow speeds, to exclusive right-of-way, much higher speeds. Various categories of light rail systems. So we spoke about the tram, simple tramway, single unit, normally in mixed traffic, so sharing your road space. Capacity and speed, you can see from the lower capacity, much slower. Capital cost, therefore, is much lower, moderate, low operating costs. And then if we move on to the other forms, moving now progressively to the higher forms, we have the light rail systems, then you have your LRT that we spoke about. So that it could be either on street or could be a segregated right-of-way or even a mixture, like the tram. And then moving on to the light rail metro, where you are completely segregated tracks. You have a slightly higher capacity. The metro is much longer than the light rail system or the light rail transit, LRT. It has its own right-of-way. And then we move on to the rapid rail transit. Rapid rail transit, which we commonly refer to as your metros. In places like London, they are the underground metro system. They have complete right-of-way, dedicated. higher speeds, much higher capacities. You could have up to 10 coaches per train. So certainly higher capacity. You can see some of the speeds that could go up to 100 kilometers per hour. Very good headway meaning from one train to another. So if you miss a train, you don't have to wait long for the next one to arrive. So nothing for nothing, you got to pay for a better service. So the capital cost is certainly higher. And you have your operating costs. And in terms of revenue, yes, certainly it is quite expensive to operate. So certainly one public transport operator will apply for subsidy from the Department of Transport or the subsidy provider. And then you have your suburban rails, which is similar to our commuter rail system that we have here, where your surface rail system. And then if we move on then to examination of these existing systems in terms of firstly the performance. So when we talk in terms of the performance of the existing system, you can see from that slide that one can determine performance, how well the transport system is operating, by simply measuring the degree of overcrowding. So that is one rule of thumb method. We refer to this as a rule of thumb method. It's nothing cast in stone, but it gives you some indication in terms of the performance of the existing system. So we could judge the performance of the existing system either by measuring the degree of overcrowding, or for that matter, the travel times, or even the fare. How much is the public transport operator charging the commuter? Is it too much? Is it more than 10% of the income of 50% of our population? And these values are taken out of the white paper that I spoke about at one of the lectures. So with terms of overcrowding, you can see there's reference made to page 14. So if you go to page 14, you will see on page 14 overcrowding and what constitutes poor performance relating to overcrowding. So if you had to, for example, stand at a bus stop and if more than 2 or 3 buses passed you because they were full and you were not able to get onto the bus, then that will constitute overcrowding. On the other hand, if you were standing at the bus stop and you stood there for more than 15 minutes and you were unable to board a bus, again because the buses were full and they did not pick you up, then that is considered as overcrowding. Okay, so if you read through that paragraph on page 14, you will see that information given there. And then the second one that's reflected on page 14 deals with your excessive travel time. And you can see also with excessive travel time, it relates to the amount of walking that you got to do to get to the public transport pickup point. And also, for that matter, the distance traveled, how long it takes you to travel X distance, whether it's 6 kilometers, whether it's 10 kilometers, how long it takes you. And there are values given like 60 minutes, 1 hour for a 10-kilometer trip. Then these could then fall under excessive travel time. And then like the last one there would deals with the fare or the service. You will see, as I said, that was taken directly out of the white paper. So in other words, if it costs more than 10% of your income for more than 15% of the population, then it is considered that that fare structure can be considered to be discriminatory. Okay, so and you can see now with the increase in fuel price, how public transport fares have increased in recent years. And if one had to then do a comparison, perhaps it affects more than 15% of the population now, spending more than 10% of your income. Okay, so that's some information on performance of the existing system, and you can supplement that by referring to page 14 in your notes. Root causes of deficiencies, yes, obviously opportunities for improvement. So when we talk in terms of inadequate transit equipment, we're referring to poor condition of equipment, not enough vehicles in running conditions. So obviously, if you're going to run a system like this where your vehicles constantly break down, you don't have enough vehicles to cater for it, in other words, to give a good frequency of service, then certainly commuters are going to shift to some other mode of public transport. You're going to lose business. So some ways that one could improve your transit vehicles, and you could improve it by, when we talk in terms of softening the regulation, what we mean is that we try and encourage more investment by private sector. So by encouraging more investment by private sector, that will also help in improving the system, improving the condition of the equipment and so forth. The other one bullet that you have there is with regard to tax. Yes, if you can make, you could soften the tax burden, and you see there in brackets you have tax omission versus tax evasion. Now one is legal, one is not. So which is the illegal one? Tax omission or tax evasion? Anyone? Which is the illegal?
Tax evasion.
Yes, certainly tax evasion. So yes, with tax omission, you can find ways where you can get back more from the taxman. In other words, give the taxman less, which is legal, but obviously you'll have to provide sufficient motivation and evidence as to why you're expecting some rebate on a particular issue, particular area. So that can be covered under the tax omission category. And encouraging public transport operators to improve their cost effectiveness. Yes, certainly you want to try and make your system as effective as possible, cost-wise as well, and to try and invest in additional transit vehicles. By investing in additional transit vehicles, you're trying to address the issue of frequency of service. So a commuter does not have to wait very long for the next public transport carrier to arrive. So in terms of poor transit operations, yes, you can see there inadequate equipment, or you need to have adequate equipment. How can one improve the transit service? So we spoke in terms of incentives for higher productivity. So even incentives for fare collection, incentives to the driver, to the conductor. So the whole range that one could look at relating to the incentive issue. And then when we look at also in terms of employer-employee, you must have a very good relationship, good employer-employee relationship. Otherwise, you are running a system, and if that does not exist, your employee will take you for a ride. When I say take you for a ride, will swindle half the fare. You wouldn't even know it. So that's very important when you are dealing with staff and so forth. And the third bullet speaks more in terms of freedom to choose routes, size of vehicles, and frequency of service. Yes, while it's good to do that, one needs to look at the situation in South Africa. So that bullet can become a bit debatable, especially if two public transport operators are operating on a single route, a particular route, and that could lead to taxi wars and so forth. So it's very important how you control that and monitor that and regulate that. So that is very important. The next bullet deals with competition. Yes, any form of competition is good. So by maybe reducing the fare on your public transport mode, you could attract more commuters. So at the end of the day, the end result is a benefit to your commuters. And then the last one, yes, one should consider the authority, the government, National Department of Transport should look at introducing or having subsidizing your public transport users. Here in South Africa, all our rail network, they are subsidized. Most of the bus operators are subsidized. Most of them, some are not. The minibus taxi operators were not subsidized, and therefore you may have read or heard over the years the debates going on and the issues that were raised by the minibus taxi operators in terms of requesting for subsidy. So there's a lot in terms of public transport operation and debates that's going on at present in South Africa. What has also added to that, compounded that, was the regulation of the minibus taxi industry, and now the implementation of the BRT system, the bus rapid transit system, that many of the minibus taxi operators objected to the BRT systems, claiming that it will take away the business from them. So there has been a lot of debate around that, a lot of talks going between the authorities, between the municipalities and the public transport operators, trying to get the Minibus Taxi Association to buy in to the BRT system by either giving them so-called shares in the system, so they have some incentive to support the system. So there's various talks and so forth going around regarding the BRT system as well. So street congestion then, very often this is caused by poor public transport organization, operation, and so therefore one needs to have proper traffic management measures or techniques in place to try and avoid or prevent street congestion. You can see a few bullets given there. So the first sort of measure technique is to try and restrict on-street parking. So you create more road width, more movement, more capacity, preventing stopping of your vehicles during peak periods on busy streets. Those are some of the ways that you can prevent congestion. And you can see the second bullet that deals with street trading. I'm not sure how many of you drove into the Durban CBD recently and looked at all the informal traders alongside your roads. Some of these street traders have even encroached onto the parking base, which has either, certainly limited the effective width of the road, limited parking space, resulting in some motorists double parking. In other words, parking on a lane. You now reduce the effective width of the lane, and certainly that will have a direct impact on your capacity. It will reduce your capacity. It will promote traffic congestion, street congestion. So proper control of street trading is important. Third one, reducing conflicting traffic movement. Now you see there the mention of intersections as well, at grade. Intersections are at grade, same level. One road crossing another road. So you could have, and I mentioned this at a previous lecture, your intersections are one of your main reducers of capacity, because your vehicle needs to get to the intersection and either yield or stop. If there's a traffic light, certainly stop if it's red in your direction. So how can one then try and improve the capacity at your intersections to try and prevent vehicles queuing at your intersections, prevent backlog at your intersections? And you can see there's various techniques. I spoke about one where you optimize your signal settings. And I gave you a typical example where you had to investigate why there were so many vehicles turning right at a particular intersection at the expense of oncoming vehicles. So they were taking the chances turning right, and that created a red spot on that road in terms of possible collisions, head-on collision. Okay, so, and I did say that perhaps a new industrial area may have come up on the right of that intersection, hence more vehicles are now turning right. And one of the traffic management measures or techniques could be to introduce a separate signal, a priority right turning arrow, green arrow, to allow vehicles to turn right, to stop vehicles in the opposing direction and have a priority right turning arrow to try and create or to try and prevent congestion, to try and prevent vehicles queuing at that traffic light. So these all fall under reducing conflicting traffic movement. And the other one you see there mentioned is one-way streets. And I did give you a little tutorial exercise. I'm not sure how many of you did the exercise, but I did give you a tutorial exercise and I did say to you, draw sketches of 3 intersections. The first intersection where you have one road intersecting with the other road, traffic in both directions. The second intersection, I did say one of the approaches converted to a one-way street, so traffic in one direction only, while the opposing lane maintain two-way traffic. And then finally, I said the third intersection where both approaches are one-way. And I said to you, plot all the points of conflict on intersection 1, 2, and 3. And you will see how your points of conflicts are reduced from intersection 1 to intersection 2, and then further reduced from intersection 2 to intersection 3, the one-way street. So you can see what you've done. You've now reduced conflicting traffic movement. You've obviously made that intersection much more safer. You've improved capacity at that intersection, and certainly you addressed the issue of congestion at that intersection. Certainly enhanced that. So reduced congestion. So, and you will see many CBDs have gone this route. If you go back many moons, West Street in Durban was two-way traffic. Smith Street was two-way traffic. No more. It's now one-way, isn't it? You take any city, Pietermaritzburg, Long Market Street previously was two-way. Now it's one-way. Church Street was two-way. Now it's one-way. So you can see, you can do a little exercise and see why, what's the rationale to implement one-way streets. And you can see the reasoning behind that. You can see the next bullet in terms of restraints on use of uneconomic road vehicles. And this is mainly pertains to private motor cars, to try and, like we spoke about at the last lecture, restricting private motor cars to get into high density zones, into the middle of your CBD area and so forth, by having special tolls charging vehicles to get into your CBD zones. Increasing the parking rate at your street parking as well as your parking malls, if you want to call it. So there's various techniques that one can apply. And then the last one, which is a more expensive traffic management measure, and that's providing flyovers. When we talk in terms of flyovers, you can even bring in your interchange, where you have roads crossing grade separated at different levels. Another important one is providing pedestrian bridges, foot bridges, and you've seen this if you're traveling, for example, coming into the Durban CBD past the Beria toll bridge. You will see the pedestrian bridge then, and it's all over. If you look at, for example, the Gateway complex, the new interchange that came about, I'm talking in Mshlanga, you will see a dedicated footbridge also there. But unfortunately, recent research surveys that were conducted with regard to the effectiveness of these footbridges didn't prove too good. Didn't prove too good in a sense that not many pedestrians are taking the initiative to use these dedicated footbridges that were built there at quite a cost. They'd rather cross a 4-lane, 5-lane highway and get run down by a motor car. So this was another research area that the National Department of Transport was embarking on, the effectiveness of these pedestrian footbridges. And numerous surveys were done where these footbridges were installed, constructed, and it was found that a high percentage of the pedestrians chose to cross over a busy highway, freeway, than use these dedicated footbridges. So the next time you are traveling on the road, you can also do your own observation. Okay, so that then brings us to the last mock test for pertaining to transportation systems. We did one at the last lecture, so this is the last one pertaining to transportation systems. And yes, it comes under the vehicle characteristics and driver characteristics chapter or module, namely module 3 that you covered, that dealt with side distance, dealt with the skid distance and questions relating to skidding. And you can see here on this slide, there's also the first two questions that deals with EVU ratings. This is nothing new to you. You've covered EVU ratings, you covered DHV, design hourly volumes, 2A, transport technology 2A. So it's certainly nothing new to you. You should still know the calculations, how to do the calculation. And there's nothing stopping the examiner in your 3A to quiz you on a 3-mark question on EVU rating and DHV calculations. So you should know it, like it's appearing here on this. It did appear, you can see the reference right on the top, it did appear in the 2021 mid-year control test. So that semester we had to move from exams to major control tests, 2021 mid-year. COVID numbers were high. So I'm sure you all remember that you perhaps were at your S2 level or S1 level. So very briefly then, an overview of what you covered at 2A. When we talk in terms of EVU, what is EVU? EVU stands for your equivalent vehicular unit. You may have also used the terminology or acronym PCU. PCU stands for passenger car unit. So if you are designing a particular road, one of the data feedback that you should get is a volume count. Having some data is better than no data. You could end up upgrading a road or constructing a new facility, a new road. And the moment you open the road to traffic, it could be running at capacity, which means you have under-designed. So therefore, volume counts give you a good notion in terms of the amount of vehicle and number of vehicles you could expect using the road. And also very important, what percentage of those vehicles you could expect to be heavies, your trucks and buses and so forth. And you've got to allow for your heavies, because you know that your heavies have a totally different operating characteristics compared to your private motor car. It has much slower speeds. If you put a truck on a 3 or 4% grade, the speed of the truck is reduced to crawl speed. If you have a truck at a T intersection, turning at the T intersection, mark the tracking path of the rear wheel. It encroaches onto the oncoming lane, so you need to be very clear in terms of your design of your intersection. So they have totally different operating characteristics, and therefore you need to take account of these heavies. So you need to convert your heavies to PCUs or EVUs, equivalent vehicular units. So in other words, if you observe, like in the example tutorial question 1, 1,350 vehicles, and you simply design for the 1,350 vehicles, not taking into account that 5% heavies, you could be under designing. So you need to allow for those 5% heavies. You all know there are EVU factors given here for either a 2-lane or a multi-lane road. and for the various conditions. When I say various conditions, whether the road is going to be constructed on a level terrain, on a rolling terrain or undulating terrain, or a mountainous terrain. And you can see how your EVU factors increase from level to mountainous terrain, and also whether it's a 2-lane or multi-lane. So simple, you have all done this. You've worked out 5% of your AADT, and from that 5% you applied your EVU factor to equate those heavies to PCUs or EVUs, equivalent vehicle units. And you added that then to the balance of the EVUs, which were your passenger cars. So DHV, yes, you know, you've dealt with all these acronyms, and perhaps when we look at traffic engineering, they will creep up again. What's ADT? ADT, your average daily traffic. What's AADT, your annual average daily traffic. What's DHV, your design hourly volume. And here in South Africa, for design purposes, we base our design hourly volume 15% of the AADT, annual average daily traffic. So for design purposes, we simply take 15% of the AADT as our DHV, design hourly volume. So having given you a brief overview of your 2A work, you should now be able to handle the first 2 questions. And the last 2 questions is familiar to you. You did that in Tuesday's mock test. So it's here again for you. So like we did on Tuesday, you shouldn't take more than 15 minutes. Is ample time for you to handle this final mock test pertaining to transportation systems. So your time starts now. You can get out your writing material, your calculators, and work on it. So you have approximately 15 minutes. I'm still online, and after 15 minutes, you will then mark your work. Okay, go for it. For the benefit of those that were not at the last lecture, I want to again emphasize that it would certainly be in your best interest to do the calculations on your own. Like I said at the last lecture, rather do the calculations now and get it wrong. And so that when you compare your answers, you can identify with your mistakes and you will not make those mistakes in the test or final exam. So please, I'm again encouraging you to walk through the examples on your own. Certainly defeats the purpose by simply looking at the memorandum or the model answer. You don't achieve anything. Okay, so walk through it on your own. Give you a few more minutes. All right, that was more than enough time for you to tackle that mock test. So maybe get out your marking pens. Even if you don't have a red pen, any color will suffice. And you can mark your work. So let's look at question 1. You were given a multi-lane road in rolling terrain. So that's an important point that will dictate your EVU factor. So whenever you're given a question, you should highlight the key points, like in this case, multi-lane. That also will dictate your EVU factor. So multi-lane, rolling terrain, AADT given 1350, annual average daily traffic, and of course 5% heavies. So if you work out your 5% heavies, that works out to 67.5. Obviously you don't have half a vehicle, but leave it as a decimal, it's fine. So you got your heavies 67.5. The balance obviously will be your passenger cars, which is 1282.5. Your PCUs, your passenger cars, and adding your heavies to that, 67.5, that gives you an EVU rating of 1552.5. DHV, a design hourly volume, is simply 15%, as I said, for design purposes, taken as 15% of your AADT. So simply working out 15% of your AADT, that gives you 202.5. Okay, so if you got that correct, give yourself 3 marks if you got all of that correct. And then the second one, same process, work out your heavies. You were given 8% heavies, that equated to 88.8, equivalent in terms of passenger car units, or equivalent vehicular units. The balance will be then your passenger car units, or your EVU, which is 1021.2. Add your heavies, which were converted to equivalent vehicular unit, gives you a total of 1287.6. So for design purposes, your EVU rating is 1287.6. And then finally, your design hourly volume, 15% of your AADT, that gives you 166.5 vehicles. And if you got all of that correct, then that's a further 3 marks. Brings you to the third question. And you're given the braking distance for a vehicle traveling up a grade of 100 kilometers per hour. Braking distance was given 97.55 meters. And you are required to determine the grade given the coefficient of friction between the tire and road surface to be 0.28. So you know your generic design stopping side distance formula, and you're only dealing with the D2, the braking distance, and making I, your grade, the subject of the formula. In other words, solving for I. And if you did that correctly, substituting the values given for braking distance, for design speed, and coefficient of friction, you should work out I to be 0.12380, and as a percent, that's 12.380%. Okay. Can note I did say for test and exam purposes, keep to 3 decimal places. And then finally, determine the design stopping side distance for a wet road, which has a design speed of 95 kilometers per hour. And again, you can see the examiner gave you the brake force coefficient, 0.31, which tells you that you must use the brake force coefficient formula. If you use the generic stopping side distance formula, you would have got it wrong, irrespective of having an answer close to the one given here. So the brake force coefficient formula for design stopping side distance is 0.694 V plus V squared divided by 254 F. And note in this formula, V is already in kilometers per hour. So there's no need for you to convert it to meters per second like you do in the generic stopping side distance formula. In the brake force coefficient formula, your V is already in kilometers per hour. It's important you make note of this. So it's good for you to get yourself a little formulae book, black book, and jot down all the formulae in that book and the do's and don'ts. When I say the do's and don'ts, so when you jot down the brake force coefficient formula, you put a note below that. Note V is in kilometers per hour. When you jot down the generic stopping side distance formula, safe stopping side distance formula, namely I'm referring to Vt plus V squared over 2G in brackets F plus or minus I. You all know the formula. Then note at the bottom, V is in meters per second. That formula was designed or derived considering V to be in meters per second and not kilometers per hour. So if you insert kilometers per hour in that formula, you're going to get the wrong safe stopping side distance. Obviously, you're going to get the question wrong. So make note of that. So below that formula now, you should have a note that V is in meters per second. I, your grade, is as a ratio, meter per meter, so as a decimal and not as a percent. So those are the notes, the do's and don'ts that you should be writing. So come your test or your final exam, there's no need for you to work out 100 past exam questions. Simply look at your black book, the formulae, the do's and don'ts. At the end of the day, it's the format, the procedure that is important. If you apply the correct procedure, you've worked one example, you've worked them all. Okay? Only figures will be changed to protect the innocent involved. So, applying the formula then, that gives you a safe stopping side distance of 180.548 meters. Right, so you've done that. What we had a total of 3, 6, 8, 10 marks. So you work out your mark allocation divided by 10 to give you a percent. So let's see, by show of thumbs up, how many of you clocked this mock test? 100%. Anyone? 100%. At least you're being honest, none of you. Distinction? Below 100 but more than 75. Below 100 but more than 75. Okay, 2, 3 of you. Okay. And then 50 to 74. 50 to 74. Okay, 1, 2. And then below 50. Be honest. Well, I can do the math. Below 50. So we're looking at below 50, we're looking at 50% of you, if I do the stats from the feedback you've given me. But like I said, rather get it incorrect today and check your mistakes. So go back. Obviously, you have a view of this recording. So go back and check where you've slipped up. Try and do. I suggest take down just the final answers. Go and work through it again. And then check if you've come up with the expected answers. Then look at the full working. So yes, that then brings us to the end of this lecture. In fact, I've encroached onto the second period, and the second period is your tutorial period. So I want to say that some of you may be on par, maybe ahead in a sense that you've already referred to Moodle and looked at the tutorial, the theory tutorial questions pertaining to transportation planning and transportation systems. Some of you have joined the course late, so perhaps you haven't. So I'm going to allow the balance of the second period more to those that are not on par. So you need to log on to Moodle and make reference to tutorial number 1, 2, 3, 4, and 5. And most of the questions in tutorial 1, 2, 3, and 4, and 5 pertains to transportation planning and transportation systems. There may be one or two theory questions there that's out of traffic engineering, the module or the chapter that we're going to do next week. So don't worry too much about those theory questions, those one or two. You can look at those when we cover those relevant chapters next week. But for now, you need to log on to Moodle and go through the tutorials 1, 2, 3, 4, 5, all the relevant questions pertaining to transportation planning, transportation systems. Okay, so that brings me to an end for today. So when we do meet next week, Tuesday, it will be traffic engineering. That will be the first module, or the first maybe two modules for test 2. Remember, test 2 will cover traffic engineering. It covers your Graduate Engineering Council of South Africa's EXA's graduate attribute GA4. GA4 that deals with data analysis, experimentation, and so forth. So we will then start that on Tuesday next week. So you all have all the necessary documentation, tools, questions, etc., presentation, PowerPoint presentations, tutorials pertaining to test 1. Like I said, and I mentioned this at previous lectures as well, be in your best interest to write the schedule test. We all know that obtaining a doctor's certificate from any spaza shop is very easy, but then remember that you will then, with the production of doctor's certificate, you will then be entitled to the special test 1, which is set at the end of the semester when you are under pressure to write your final exam, and that special all aspects of the syllabus. And if I can quote stats from previous special tests, the pass rate in the special test has been between 5 to 10%. The scheduled test 1, the pass rate has always been over 80%. So you do the maths. Even if you break a leg, it's still worth your while wheeling yourself to the S10 basement and writing the scheduled test. Okay, I think I've spoken enough for today. Any questions from your side? Going one? Going twice? Going thrice? Okay, then thank you for attending. So we will meet then again via MS Team on Tuesday next week. Let's try and stop the recording.